Good day, everyone. My name is Banyan Yuran, and I'm thrilled to present my work on fascinating applications of calculus in economics, geometry, and physics. Calculus is often called mathematics of change, and today I will show you how this powerful tool helps solve practical challenges. Imagine calculus as a telescope, letting us zoom in on the intricate details of how things changed, like slope of a curve or the distribution of mass.
Here is what we will cover today. First, we will explore derivatives in economics, how business use calculus to optimize production and maximize profit. Next, we will dive into the washer method, a geometrical tool for finding the volume of 3D solids. Finally, we will discuss moments and centers of mass in physicals, essential for understanding balance and rotational forces.
Derivatives in economics. Derivatives are fundamental in economics, helping us analyze how small changes in production or sales affect cost, revenue, and profit. For example, the cost function C of x represents the total cost of producing x units. Its derivative C prime of x gives the marginal cost, which shows the additional cost of producing one more unit. The revenue function R of x, representing total income, has a derivative R prime of x that tells us how much extra income is gained by selling one additional unit. Lastly, the profit function P of x equals R of x minus C of x helps businesses understand how profit changes with production through its derivative, P prime of x. Example 1. Marginal cost. Let's use an example to understand marginal cost. Suppose the cost function C of x equals 5 times x plus 10. The derivative C prime of x equals 5 shows that the marginal cost is constant. Producing one additional unit always costs 5 units. This is like taking a taxi ride. The fare per kilometer stays constant no matter how far you travel. Example 2. Revenue maximization. Next, let's discuss revenue maximization. Suppose a company has the revenue function R of x equals 20 times x minus 1/2 times x squared. To find the production level that maximizes revenue, we take the derivative R prime of x equals 20 minus x and set it to 0. Solving this gives x equals 20, meaning the company maximizes revenue by producing 20 units. Substituting this back into the revenue function, we found R of 20 equals 200. Example 3, profit maximization. Let's now explore profit maximization. Suppose a profit function is P of x equals negative 2 times x squared plus 40 times x minus 50. Taking its derivative, we get P prime of x equals negative 4 times x plus 40. Citing P prime of x equals 0 gives x equals 10 into the profit function gives P of 10 equals 150. Think of it like baking a cake. Too little effort and it's undercooked. Too much and it burns. Calculus helps businesses find the sweet spot. The washer method helps us calculate the volume of solids formed by rotating a region around an axis. The formula is V equals pi times the integral from a to b of r of x squared minus r of x squared dx. Here, r of x represents the outer radius, and rx represents the inner radius. Let's apply the washer method to a region bounded by y equals x squared and y equal 4. Rotated about the x-axis. The outer radius is r of x equals 4, and the inner radius is r of x equals squared. Using the washer formula, we calculate the volume as V equals pi times the integral from 0 to 2 of 4 squared minus x squared squared dx, which equals 128 pi over 15. Imagine this as constructing a donut. The outer shape gives the structure, and the hollow center is subtracted to get the final volume. Washer mesh application. The washer mesh is commonly used in engineering to calculate the volume of objects that are created by rotating a region around an axis. This mesh is especially helpful for these 4 areas. 1. Designing tanks and pipettes. 2. Fluid flow analysis. 3. Material efficiency. 4. Aerodynamics and turbines. This technique provides an accurate way to model 3D shapes and volumes, essential for optimizing design in various engineering fields. Moments and center of mass. The moment measures the rotational effect of a force, while the center of mass is the balance point of an object. The moment is calculated as m equals the integral from a to b of x times rho of x. The center of mass is given by x bar equals the moment divided by the integral from a to b of rho of x. These concepts are vital in physics and engineering to ensure stability and balance in structures. A moment is the sum of each part of object's mass multiplied by its distance from a reference point, usually orange. Usually origin. Rho of x is a density function which shows the mass per unit length at position x. The number gives the total moment mass times distance from the reference point. The denominator gives the total mass. This formula helps find the balance point of the object, where the mass is evenly distributed. Example, center of mass. For a rho of density function rho of x equals 2x plus 1, we calculate the total mass of integrating rho of x from 0 to 1. Similarly, the moment is found by integrating x times rho of x over the same range. Dividing the moment by the total mass gives the center of mass, approximately x bar equals 0.583. Imagine balancing a broomstick. If your finger is at the exact center of mass, the broomstick remains steady. Conclusion. In conclusion, calculus is far more than a collection of formulas. It's a versatile tool that bridges the gap between abstract mathematics and real-world applications. For optimizing production and maximizing profit in economics to calculating volumes of complex shapes in geometry and understanding balance and stability in physics, calculus empower us to solve problems that once seemed insurmountable. It's like holding the key to unlock the secrets of change and the structure in the world. Think of calculus as universal language, a way to describe how things grow, shrink, balance, or rotate. By mastering its principles, we gain not only a deeper understanding of mathematics, but also the ability to apply it in meaningful ways. Let me leave you with this thought. Understanding calculus helps us understand the world. It's not just about solving equations. It's about seeing the connections that shape our lives and universe. Thank you for your attention. I would be delighted to answer any question you may have.